All right, we are starting 1-4, talking more about angles. Today, by the end of the video, you should be able to identify adjacent, vertical, complementary, supplementary, linear pairs, and then use those to find measures of pairs. So there's a lot of vocabulary going on again today. First thing we're going to talk about are adjacent angles. Adjacent means right next to. You can think of them as neighbors. So they share a same vertex, that's the point where the angles make, and they have one common side. So for example, angle 1 and angle 2 are adjacent angles because angle 1 and angle 2 share this ray. So these are called neighbors, these are adjacent angles. If I gave you something like this, let's call this A, B, C, and D. If I gave you ABC and ABD, these would not be adjacent angles because ABD is inside ABC. So it's important that they share a ray, yes, but they're not inside of one another. So that's adjacent angles. They're right next to, they're touching. They're neighbors. Linear pair are always adjacent angles. So they're angles that are right next to each other and sharing a ray, but they make a straight line. So when you add them up, they make a straight line. So examples, angle 3 and angle 4 are a linear pair because notice they share this common ray. And when you look at those other rays that are not common, so if you look at this ray from angle 3 and this ray from angle 4, it makes a straight line. So I would also write down that a linear pair is going to always add up to be 180 degrees. So I want you to think and answer this question. Okay, so for example 1, it wants you to tell whether the angles are only adjacent, and form a linear pair, and are not adjacent, excuse me. Because it's important that you realize that if I give you a linear pair, it's always going to be adjacent. But adjacent angles aren't necessarily a linear pair. So linear pairs will always be adjacent. Adjacent angles don't necessarily add up to be 180 degrees, like this one isn't 180 degrees. That's that's a cute angle. Okay. Example 1. So AEB and BED. So that's from this angle, from this picture, excuse me. So angle AEB, A to E to B. They're talking about this angle. And BED, B to E to D. BED is this yellow angle, B to E to D. So if you look at it, they do share this ray. So that means that they're going to be adjacent since they share BE. They both have BE in it. And then if you look at their other rays that aren't common, if you look at this one, and then we said this one, they make a straight line. So it's adjacent and a linear pair. I'm going to do the first 3 for you. Okay, so let's look at the next one. Next one is AEB, so A to E to B again. That's this angle. And then BEC, B to E to C. That's this yellow angle. Okay, this one. So if you look, they do share BE again, so that means that automatically they're adjacent, they're neighbors. And then, but if you look at those other rays, so if you look at AE and EC, the ones that were not common, they do not add up to be a straight line. They are obtuse, but it's not 180 degrees. So it's just adjacent. Okay, so then last one, number 3, says DEC. So D to E to C is talking about this angle, and AEB, A to E to B is talking about this angle. Some people are going to think that it's a linear pair because if you look at it, it makes a straight line, but it has to be adjacent. They don't share any of the same rays. This one doesn't intersect this one, doesn't overlap this one, doesn't overlap this one. So it is nothing. It is not adjacent. It is not a linear pair. For 4, 5, and 6, you're looking at this picture. So go ahead and see if you guys can answer 4, 5, and 6 on your own. You can pause the video if you want to. Okay, example number 2, finding the measures of complements and supplements. So complementary and supplementary angles are more vocabulary. Complementary are 2 angles that add up to equal, I'll put add up to 90 degrees. I want you to also write down that they do not need to touch. Okay, so complementary angles add up to be 90 degrees. Supplementary are two angles again, and they add up to be 180, 180 degrees. Again, they do not need to touch. Okay, so an example is I could have a 30 degrees, oh, that kind of doesn't look like a 30 degrees, but there's 30 degrees right here, and here's 60 degrees all the way over here. If you add up these two angles, are they going to equal 90? Yes. Since they equal 90, we could say that these angles are complementary. They could very well touch if we wanted to. So for example, in geometry, this box means 90 degrees. It means a right angle. So if I went like this and told you that this part is 30 degrees and this part is 60 degrees, well, we add them together and they also equal 90 degrees. So we could say that these angles are also complementary as well as adjacent since they share this ray. Okay, so I'm going to do 7 and 9, 10 for you. And then you guys are going to try to do 8 and 9. Okay, so 7, it says find the complement of angle F. So here's angle F. We know complement means 90 degrees. They have to add up to be 90 degrees, right? So if one angle is already 59, what would the other one have to be in order to equal 90? Well, you just subtract. So that means that the complement is going to be 31 degrees because 31 plus 59 makes 90. Okay, so number 8, you kind of do the same thing, except you're going to have to subtract it from 180. 9 and 10 are kind of funky because I don't tell you what this angle is already. I don't give you a nice number like 59 degrees. And this one always confuses people, but if I want to find out what the supplement of angle G is, well, supplement I know means it has to be subtracted from 180, but I don't know what this angle is. So I'm just going to put in what I do know. It's 7x minus 10. You cannot solve for x. You're going to distribute that negative sign. So you have 180 minus 7x minus 10, and then you're going to combine like terms. So 180 minus 10 is 170 minus 7x. That's going to be what the supplement is. I know some of you guys are like, man, I really want to solve for x. You can't. Sorry. You can't solve for x. I haven't given you enough information. Okay, so you guys are finishing that rest of the page. We're almost done. Put a big star next to example 3. This is the hardest type of question, and I will go over this in class. And also, if you have highlighters, I would highlight these two facts. They're very, very important. Okay, so last two things we're going to talk about. Example 5, identifying vertical angles. I love vertical angles. I know I'm such a dweeb, but they're my favorite. They are not adjacent angles. That means they are not sharing the same ray. If you look at like an X, okay, and let's say I give these angles numbers, 1, 2, 3, and 4. Angle 1 and angle 3 are going to be congruent to each other. They're going to be vertical angles. Are vertical. So if you look at an X, they're ones that are completely opposite of each other. So 1 and 3 are going to be vertical angles, and 2 and 4 are going to be vertical angles. Okay. All it's also important is that they are always congruent to each other, which is why we use these so much in geometry, it's not even funny. So I would write down angle 2 is congruent to angle 4 because they're vertical angles. And if you look at this, angle 1 and angle 3, they're acute angles, right? Like let's say they're 10 degrees. Well, then that means angle 3 has to be 10 degrees. And then I'll explain why later, but angle 4 would have to be 170 degrees. This is an obtuse angle, right? So that means angle 2 would also have to be 170 degrees. And we'll get into that more a little bit later. So I'm going to do number 12, and then you're going to do number 13, and then we're going to do number 14 together in class. Okay, so number 12, name the pairs of vertical angles. Well, it would be easy if I'd given you numbers, but I didn't. So I'm going to start off by looking at the yellow ones first. So the yellow angles, to name them, that's angle HML, HML, and since they're vertical, we know that they're congruent. It's congruent to JMH, JMK, excuse me. So that's one pair of vertical angles. And then if I wanted to look at the red ones, that's these ones, I could say that angle HMJ is congruent to angle KML. And if you just want to check yourself, these ones are both acute, so yeah, they're going to be congruent. These ones are both obtuse, so they're going to be congruent. Okay, we learned a lot today. Make sure you go ahead and finish those rest of those problems. Fun fact of the video, the first concert I've ever saw live was Shania Twain. Boom. Fun fact